Now let's look at O of log n. And to demonstrate this, I'm going to bring up a list that has items 1 through 8 in it. And for what I'm about to do here, for this demo, you have to have sorted data. And what we're going to do is find the most efficient way of finding a number in this list. So we're going to look for the number 1. And of course, we're not going to know where it is in the list. We have to find the most efficient way that would work for finding any number. So this is what we're going to do. We're going to take the list, we're going to cut it in half and say, is it in the first half or is it in the second half? Well, it's not in the second half, so we can remove that. And now we only have to search through this many numbers. And then we'll do it again. It's not in the second half, and we can remove those. And we do it a third time, and we find the number that we're looking for. So let's bring all of these numbers back and count how many steps we had to find the item that we were looking for. It was 1, 2, 3 steps. So we had 8 items in the list, and it took us 3 steps to find a number. And it just so happens that 2 to the third power is 8. So we're not going to get heavy into the math and logarithms and things like that. We're just going to do something basic here, but I'm going to take this equation here and turn it into a logarithm. 2 to the third power equals 8 is the same as saying log sub 2 of 8 equals 3. Okay, so let's put this back again and watch how all the numbers move. So what you're basically saying is 2 to the what power equals 8. 2 to the what power equals 8. Well, it's 2 to the third power. Another way to look at this is how many times you have to take the number 8 and divide it by 2 to get down to one item. And that is 3 times. But the real power of this is when we have very large numbers. Let's say we have log sub 2 of this number. This is over 1 billion. How many times do you have to cut this number in half to get down to one item? And that is 31 times. So if you think about a list with 1 billion items in it, if you're going to iterate through that linearly from beginning to end, you could have over 1 billion operations. But if you do this process of cutting it in half repeatedly, you can find any number in that list in 31 steps. And that is the power of O of log n. So now let's take a look at this on the graph. You can see that it is very flat, very efficient, not as flat as O of 1, of course, but it is far more efficient than O of n or O of n squared. So these 4 are going to be what we see for most of the course, but there's one other I want to show here, and that is O of n times log n that is used with some sorting algorithms, and we'll see a couple of those in this course, merge sort and quick sort. And this is the most efficient that you can make a sorting algorithm. Now, there are some sorting algorithms that can sort just numbers that are more efficient than this, but if you're going to sort various types of data, you're going to sort strings, this is the most efficient that you can make a sorting algorithm. But for the rest of the course, other than those sorting algorithms, these will be the 4 that we see. All right, that is our overview of O of log n.